Okay, so let's start. We're gonna talk about today is oligosaccharides. We'll focus on disaccharides. So oligosaccharides. So first of all, oligosaccharides is averagely, we say 2 to 10 carbon. And then with dominant, usually is dominant with 2 carbon. And we'll give you several examples. So once it is 2 carbon, we also call it a disaccharide. This is what you know about it. Now, once we have a disaccharides, there is something we call it glycosidic bonds gonna be forming between those monosaccharides. So therefore, we need something called glycosyl, those type of chemicals. Now, where they comes from? There is a 2 way we gonna come. Number one is they coming from hydrolysis of polysaccharides. Now, not only from polysaccharides, they could come from like a glycoprotein, glycolipids, all those type of, we call it polymers. And the second way it will come in, which is coming in a digestible tract or digester tract, then rely on the enzyme, and that enzyme is called glycosyltransferase. So that's neither enzyme. Now, we want to mention this is that the disaccharides usually in our environments is not too much, not as much as monosaccharides. Majority of them, they are coming from is hydrolysis is polysaccharides in our environment. Now, obviously, we want to talk about these 3 examples. So there are some examples is we're going to talk about is maltose, lactose, and sucrose. And because sucrose sucrose, and because sucrose is the table sugar, so we will talk about how the basic steps of manufacturing of the sugar today. Okay, so that's what we're going to talk about. So let's first talk about is the maltose. So first of all, what is maltose? Maltose is composed by 2 glucose. Basically, it is alpha glucose with beta glucose. Now, of course, we call it combined with 1,4 glycosidic bond. So what it looks like? Okay, so we're gonna draw it. And you should be familiar with what is the glucose looks like. So if it's alpha glucose, this is H, this is OH, we go down. This is called anomer. Is that right? Isomer, anomer. So go H, OH, here, OH, H, and go here will be OH, H, here, CH2, OH, and here is H. So this is, we call it alpha glucose. Now be careful, this is called alpha because it's go down. If the OH is up, we call it a beta. Now, what is beta glucose? Okay, so let's draw right here. This is so easy, that's not difficult, but it is important when you get to know, because these things looks very similar. Go H up, H, H, OH, go here, OH, H. Then go here, we'll have OH, H, H, CH2, OH. Now, by the way, we can label those carbon, which is 1, 2, 3, 4, 5, 6. Same thing, 1, 2, 3, 4, 5, and 6. Okay, what's going to happen then? Remember, we talk about here, the structure is an aldehyde, but we call it hemiacetal. And then here, what it looks like? It looks like an alcohol, not really alcohol, okay? We call it alcohol, quotation mark. So when they combine, what's going to happen? They're going to lose one molecule of water. So what it's going to be looks like then? Okay, it's very simple. Goes here. It's going to be H. Going to be like that. Okay. So you can go ahead to draw all of the others. Okay, go here. This is a key that we want to mention. CH2, OH. Okay, so right here they connected. Okay, now the question. Is this a reducing sugar? Yes. Is that right? There is a free aldehyde there. So it is a reducing sugar. Now lots of the textbooks, they want to make sure you understand. So how they do it? They roll like this. Okay, so you know it is a reducing sugar. 1,4 glycosidic bonds. Right here, 1,4 glycosidic bonds. Acidic bond. Okay, so it's a reducing sugar. Now, where going to be the maltose comes from? The next question. Maltose in the environment, lots of the time, they coming from a starch. The starch, we know there is an enzyme can hydrolyze, which is called beta amylase. And we will mention there is a different enzyme to cut different branches and the linear link of the starch, then become maltose. So this is the first way we do. Second, let's say this is one. The second, sometimes there is some plants, there is a no amylase. What is that? That's barley, which is used for beer brewing. We'll talk about beer brewing real quick next week. Okay, we wanted to hydrolyze starch, but we don't have it. What we do? The barley, we have to do what? A process called malting. Then this malting will create maltose. Because we don't have amylase, we have to do a malting process. Okay, we'll talk about detail. Now the last thing is that we don't do malting, you don't have amylase, then what we do? You're gonna add bacillus. Bacillus subtilis, let's say. Subtilis. So remember, this is what we did in the general microbiology lab. We have bacillus grow there, and we have an E. coli there as a control, then what you see? There is a transparent zone surrounded. Is that right? But sometimes you don't see it. So what we're going to have to do? Pour iodine. Is that right? Lots of the time we do this, we do see the transparent zone, but this one we're not going to see, so we pour iodine. If the iodine is brownish, that means the starch is still there. If the iodine is not brownish, that means the starch is gone. Because the bacillus has amylase, it will be hydrolyzed starch become maltose. So that's another way in the industry they do, they add bacillus substitutes. Okay? Now the last thing I also want to mention is that this maltose, they also have a related sugar alcohol is maltose. And this is used, can do like sugar-free chocolate as a replacement or as an alternative stuff. Okay, so this is something I want to mention is for the maltose. Okay, the next one I want to mention is glucose. Do you mind moving a little bit? Thank you, Michelle. Is the lactose. We have several things we want to talk about lactose. Lactose also a very common disaccharide. What it is combined with is, I would say it is a glucose with alpha or beta. It's both are okay. Or we can say a beta glucose with, let's say, alpha lactose. Okay, now of course it's one for glycosidic amounts. So what it looks like. So we want to draw this. Okay, you can understand very well. So if it's beta, we go up, go down, and go here, which is H, OH, OH, H. So we go OH, H, H, CH2, OH. Okay, now, what is galactose compared to a beta glucose? Well, all we just said, what is the difference between galactose and the glucose? What's the difference? So we draw here. And we mentioned about last lecture, if you still remember. So let's say it's alpha galactose. So we're gonna go down. H, H, OH, OH, H, CH2, OH, H. The key is right here. What's the difference? Carbon number 4. Remember we say glucose and galactose is carbon 4 epimer. So what's the difference right here? If this guy is go down, in galactose this guy should go up. So what it looks like? This guy gonna go up, and this guy is go down. Okay? Now, for this one, usually we want to differentiate between here and here. So we give an example. We usually don't use beta as an example, although it widely existed. Remember, 64% is beta glucose, 36% is alpha glucose. We usually do like an example. From the chemical standpoint, we use alpha as an example. It's like this. Okay, so how they connected? Still semi-acetal, hemiacetal, so they connected like this. Okay, so they become a lactose. Okay. Now, we want to mention several things about lactose. Number 1, lactose is widely existing in milk products, or we say dairy products. So milk products, every averagely is 2 to 8.5%. With cow milk, literally around like 4.5%. Goat milk, it is about 4 to 4.5% similar. Human breast milk is a little bit high. Could be up to 7%. But the range is 2 to 8.5%. That's for the that's a lactose. Okay. Now, second one, obviously, when you see this guy, this is the reducing sugar. Same as maltose. Okay, now, lactose, there's a problem happens in the nutrition. We talk about nutrition, dietetic, which is called lactose intolerance. So what happened? Very easy example. If you are drinking milk, you're going to have a diarrhea after that, or cramping. Now why? The reason is the lactose normally, it should be breakdown, become lactic acid or lactate. At the end of course it's going to become glucose first, lactose first. They need an enzyme, which is called lactase. This lactase, we also call it beta-glycosidic bonds. Galactose, TOS. But what happened is, some people have a limited amount of the lactase, beta-galactose. So they cannot completely hydrolyze of the lactose, become lactic acid and the lactate. So what's going to happen? Okay, I have a lactose, this is a lactose. Let's say this is intestinal. Once you still have a lactose cell, what's going to happen? This water going to point. Epithelium, is it right? The lumen epithelium, the water going to come in. Because if you still have a lactose there, it will cause osmotic unbalance. So the water going to pour in. Attracting all the water, when the water accumulated, what's going to happen? Water diarrhea could be. Another thing is that, you know the bowel movements, how are you going to improve the bowel movements? Some doctors say, you eat some acid products. You have a lactose, more or less you can use some. The lactic acid will generate acid. So there's acid there, a limited amount of the acid there, then the lactose is there. It will double trigger the bowel movement, and plus you have a lot of water, so you have a cramping and you have a diarrhea. Now this is called the lactose intolerance. Now lactose intolerance, we want to mention, it is not rarely happens when you just born. When you just born, you don't have it. Usually it's developed when you're more than 6 years old, gradually developed, and your body loses the lactose. Okay, lactose. So with those type of people, what we should do? There is several ways we can to combat or to conquer the lactose intolerance. Number one, you have to eat some fermented products. Okay, so fermented dairy products, because when you eat fermented products, then the lactose will become lactate later. So the lactose is gone. The second thing what we do, you can, instead of you drink milk, you drink a milk powder. Lots of the dry milk powder You dissolve it in the water, then you drink it, it's not have a problem. Because when they make the milk powder, they use a dry freezing. They take out all the lactose and they added lactase, which is galactose. Okay? How about last one? Let's make it easy. You just eat some lactase. Okay, as a supplement, as a dietary supplement. Just add some enzymes in, so you solve the problem. And that very often happens for the, I would say 70% of the adults in the Asian countries, they have a lactose intolerance happen. So the way to do is doing like that. Okay? So that's something I want to mention. Now, lactose, there's another thing I also want to say is, since you have a lactic acid there, but lactose, why still survive? Why still present? Lactose is a little bit, I would say, relative resistant to the acid imbalance. And this is different from what we're going to talk real quick about sucrose. Sucrose is very sensitive to the acid. You add a little bit of acid, it will be hydrolyzed. Okay, so this is something we want to mention about the lactose. Now, last thing I want to mention, but not going to talk too much. This is some very important stuff come out. If you have a lactose with glucose, let's say for E. coli bacteria, the bacteria are going to use the glucose first. Is that right? Then they're going to use the lactose. It's called a dioxic growth curve. If you remember, during the general microbiology we talk about it, because they are controlled by a lacto-operant. Regarding lacto-operant, which is both positive and negative control, it's in the genetic regulation area. We talk that a lot in all the kind of classes. So I'm just going to skip that. And some food chemistry textbooks still spending a huge amount of talk about that, but I will just skip it because that's, I have another separate video in the teaching channel, which is you can look about the lacto-operant, which is talk very detailed. So just want to let you know. Very dramatic situation when the glucose and the lactose grow together. For the bacterial cells, they use glucose first, then they use lactose. And once when the glucose is gone, then they use, because there's a lacto-operant behind it. Lac-operant behind it. That's both for the positive and negative control. Okay. So this is for the lactose. Now we want to mention the next one is sucrose. So number 3, we got about sucrose. Okay, what is sucrose? Sucrose is combined with alpha glucose and with alpha fructose. Now, why make sucrose is so special? This glucose, galactose, glucose, they are all the similar stuff, which is the aldose, which means the aldose sugar. Fructose this is the aldose. This is the ketose. Or we say aldohexose and the ketohexose. So that's because of the keto there, which makes it a little bit different, a little bit special. So what did it look like? We go talk about it again. Okay. So we have, let's do alpha, H, OH, go down, H, OH, H, OH, H, here, OH, H, CH2, OH, H. When you have become a glucose, it's different. Although the chemical is the same, what are going to be the difference? It looks like that. So what about here? CH2, OH. Then you become OH, H, H, OH, and then CH2H. So how are they connected? Kind of like that. Okay. Once this happens, this is the acetyl bond. And we also call it carbonyl link. So once this happened, what's the difference? There is no free aldehyde. Once there's no free aldehyde, by the way, this is not aldehyde. Okay, this is not aldehyde, don't confuse. You have right here, you have right here, see right here? And this one, we also, some textbook you can draw like that. There's a free aldehyde there. Here is not. So, this is not a reducing sugar. Always remember, this is not a reducing sugar. So, very easy to say. If we want to do a conclusion, we mentioned about that before. Maltose, lactose, both of these, which is head to tail link. That is 1 to 4 glycosidic bonds. How about sucrose? Sucrose is a head to head link. It is carbonyl to carbonyl. Therefore, this is a non-reducing sugar. So we mentioned about sucrose will not be easy to have is Maillard reaction, because Maillard reaction we need to have a free glucose to become a glucose CME. So how about sucrose to have a Maillard reaction? They need to cut down this. So become glucose and fructose first. Then they're going to start to have a Maillard reaction. Now the question is this a good thing? Yes, it's a good thing for sucrose. Because it's not a reducing sugar, therefore, this one is relatively, I would just say relatively, not relatively resistant to oxidation. Okay, that's why it is dramatically or a huge amount existing in the plant. What are the plants they have? Sugar cane. What else we have? Sugar beets, very good, sugar beets. Okay, sugar cane and sugar beets, what we're gonna make is table sugar. Okay, we're going to get to that real quick. Okay, so what is the table sugar? We're going to talk about is manufacturing. This is question number 5. We're going to talk about manufacturing of table sugar. Okay, so that's what we're going to talk about today. And little bit of detail, not go every single item, little bit detail. First of all, you need to know, in the United States, our table sugar is from sugarcane and or from sugar beets, we mentioned them. Sugarcane, a little bit complicated. First of all, it is a seasoning. It is not every day you have it. Seasoning basically is about summer to like a later spring to summer or fall. Never, definitely not in the winter. It's seasonally existing. Okay. The sugar cane going through the process, it will generate which is a brownish yellow sugar. But this brownish yellow sugar is pretty good, I will say, because it is 98 to 90% purity. Pretty much it's all sugar crystal. And then they have to go through a process which is called refining, or refiner manufacturing, or refiner factory. Then become edible white sugar. So that's sugar cane. How about sugar beets? Sugar beets is a little bit of difference. Sugar beets, you can do it annually, whenever you like it. Sugar beets can directly become white sugar, and basically 98%. They can skip lots of steps. So for sugar cane, when they do it, they usually in the seasoning, they do lots of harvesting. And they make a raw brownish sugar, and then they further to do a minimization, decoloring, like a further process later on. Then they keep running the whole year. Okay, so that's some overview you should know. Now we want to talk about these details. Okay, let's talk about sugar cane first. First of all, what does sugar cane looks like? I don't know you ever see it or you ever eat it. Some people say it's a grass. I would say it's like a bamboo. It's like a panda eats a bamboo. It looks like that. So how do you do? You cut it. When you cut it, it will grow. That's a very dramatic. You cut it, it grow. You cut it, it grow. Very tall. 20 inches. Some of them even 20 meters. Very, very tall can be. 10 to 20 meters, very tall. Average 20 inches, very tall. You cut it, the leaf in the surface, you cut it, it will grow. Very sweet. I used to in China, I never find it here. In China, I eat it a lot. Very sweet, because of course the sucrose is there. Very sweet, very juicy, lots of juice comes out. So the first thing what they do, they're going to do a crushing. We call it milling. Okay? Now, of course, they're going to generate is the juice. That juice is very sticky. You crush it, you mirror it. Now, of course, the leaf is, you're going to take it. Here's the thing. This juice is a little bit acid. This pH is around 4.5, maybe to 5. We don't like it. You don't like the acid stuff there, because it's going to impact the crystal. So how are we going to do? The next step we're going to do is a heat line clarification. So we go here, we do a heat line clarification. What is lime? COCaOH2. Calcium hydroxide. What's the function? A buffer pH. Is that a buffering pH a little bit? I'm not going to go to 7, maybe 6 to 7, somewhere. Okay, when you have this product, so what you're going to do? We're going to do the next step is called multiple times vacuum. We do a vacuum, and we do evaporation. Take out all the liquid. kind of like a dry. You can understand, kind of like a dry. And this needs to be two things very important. And number one is low temperature. Because if it's very high temperature, it will cause what? Thermal decomposition. So avoid thermal decomposition. This is the first thing. Control the temperature is low. The second thing is very important. After we do a multiple vacuum evaporation, there is a meter we can measure it. We need to make sure the dissolved solid is about 63 to 68%. Averagely 65%. We need it. They need a solid there. Okay. Then what are we going to do? This will be causing, next step is crystallization. Crystallization. Now how are we going to do that? This is a very important. In another vacuum pan, we have to seed it. We call it seeding with grounded sucrose or sucrose crystal. Then it will start to form in crystal. This is something called sugar crystal formation. They first of all will have a crystal formed. Then we'll have a crystal lattice, which is crystal matrix. So they're going to generate more and more. Okay? Then what you're going to do? Centrifuge. After centrifuge, what are we going to generate? Raw sugar. Like this, brownish raw sugar. Okay, there's byproducts generated. Molasses for the generator. This is the byproducts. Okay, what we do? Molasses we usually do because it's a sugar, is that right? So very simple to do is alcohol fermentation. What else do we do? It's of course it's a good energy resource. Animal feeding. In India, in China, those kind of animal feeds. But we don't use it here. Very sticky. What is this? This is a very sticky syrup. Dark brownish, even like a black color. Okay, so we're gonna have this raw sugar comes up. Is that ready to use? There's only one brand. I forgot the terminology. One brand, people use it.
Sugar in the raw?
Yeah. There's a terminology for that. One brand, they use it. Most of the time, they have to do a refining. Okay. One of the brand, I forgot about it. It's terminology kind of weird. So, then you have a raw sugar. Okay, once you have this raw sugar, what are we going to do? This raw sugar, we will recombine with water and something we call a magma. This magma is another type of like a syrup. So what's the idea of this is that you have a raw sugar. I want to take out all these impurities. So I re-added water, I re-added magma syrup to re-wash it. And this process is called affiniation. However, lots of the large sugar companies don't do this anymore because this is a high energy cost and a high expense. It's expensive, super expensive. Lots of the companies, they don't do this anymore. Okay, so let's say we did this. What are we going to do? clarification. At this time of clarification, we use double carbonation, which is you add a CO2, just like a bubble there. Okay, then you filter. Now, go into a very important step. Decoloration, amination, and softening. We need to do this. How we do decoloration? How we take out of the color? We don't like those colors. Too yellow, too brown. What we do? Two methods. Number one is activated granule carbon. This is we use in the lab sometimes, a very small granule carbon you put in a dryer. So it's going to absorb some of the color, not too effective. I don't know, industry may have a good one. Second one is ion exchange resin. Ion exchange resin also can do, what type of the ion exchange resin also can do demineralization. So minimal, gonna remove ash, what we call it. Okay, now what they do? Recrystallization, and centrifuge. Then they become white sugar. Now, of course, this guy's still gonna come out. This molasses is still gonna come out. They'll do some of the other things. Okay, that is a process for sugar cane. Sugar beets is very similar, a little bit different. The procedure is kind of similar, so I'm gonna draw here a little bit brief. Okay, so we had a sugar beets. What's a sugar beets looks like? Like a beets, like a carrot. I want to say like a carrot. Let's say like a yam, probably. Like that, kind of. So what we do? Or sometimes do V-shape. V-shape cutter. So we cut it. It's a V-shape. And we also got to do is crushing. And we call it diffusion. Now during this diffusion, what we gonna add? We are doing counter current around 85 degrees Celsius of water to do the depurify, which means the impurity we don't want it, we take it out. Okay, now go here, which is clarification. Same thing, dicarbonation, add with bubbling of the carbon dioxide. Sometimes we add this guy, sulfide dioxide, because we want to remove color at this stage. Okay, then later on is the same. This is evaporation. Now, of course, evaporation, you need to make sure dissolved solid is around 68%. And then what we do? Decoloration, demineration, and the softening, the same. Then what we do? crystallization, same thing. And centrifuge. Then we'll have white sugar. So that's basically the whole process, how we have it. And yeah, that's basically the whole process, how we do it. In the United States, the sugar cane, the sugar beets, how we get it. And then, you know, these products is like raw products. They want to make sure you don't have a lactose there. You want a sucrose, purified. So what they do is they test it with citric acids. If the citric acid will be reacted with sugar, that means it's sucrose. If it's lactose, it's not going to be reacted. Because sucrose is super sensitive, super susceptible to acid. Okay, so that's the process how we may manufacture the table sugar. So, if we want to do some conclusion, we mentioned about here is maltose, lactose, and sucrose. Now there's another thing I haven't made here. I have a slide which is if it's D-glucose with D-glucose, two alpha D-glucose come together, just becomes cerebrose. Cerebrose is making a cellulose. A cellulose is like a coat, like a cotton. That's a basic, which is a structure. Carbohydrates. It's undigestible. Okay, so that's something we mentioned in the slides a little bit on next week. Okay, so that's all we have. And next week we're spending pretty much lots of time talking about the starch.